All right, let's look at number 4. I thought this one was terribly difficult when you got to part D. Part A was kind of your gimme one. So train A runs back and forth. You've got a table. They're really keen on tables, if you haven't been able to tell yet. Train A runs back and forth, but you have to read it carefully on an east-west section of railroad track. And then it goes on to say the velocity. Find the average acceleration of train A over the interval from 2 to, that's A-rock. That's exactly what that is. And if you go from, if you do 2 to, if you go 2 to 8, if I go on this, right, and I'm not starting at 0, I'm starting at 2, the derivative of velocity is acceleration. So the acceleration, by finding the derivative, the slope, the A-rock of velocity, I have found acceleration, right? Are y'all tracking that? So all it was you have the point 2, 100, you have the point 8, negative 120, and so the average acceleration, so this is how I wrote it. I said A of t equals derivative here. I wrote slope. I try to write out anything I can just because. Now, that's not saying you need this for points, because for this, this was 1 point, and it was simply for the average acceleration. So then I said average acceleration is negative 120, and I just did the slope over 8 minus 2. Dylan, you could have left it at that if you so chose. I did take it down to negative 220 over 6 meters squared per minute, because it is acceleration. Their answer was negative 110 over 3 meters per minute. Oh, meters per minute squared, sorry. It's minutes squared. Because it's meters per minute. So you start with meters and then you go per minute, and then you do meters per minute per minute. If you did it again, it'd be meters per minute per minute per minute. Yes, keep dividing. That was 1 point. This one did not ask for this one just said the average acceleration was a point. I would say since this was just 1 point, you probably got it even if you didn't. So if somewhere on there you have this or this, I would say you got your point. Or if you even simplified it even further. All right, part 2. Do the data in the table support the conclusion that train A's velocity is negative 100 meters per minute at some time between 5 and 8? So let's look at 5 and 8. At 5, I'm at 40. At 8, I'm at negative 120. So give a reason for your answer. That's exactly what you had to say. So tell you what I said. Yes. I said yes. From 5 to 8, train A's velocity goes from 40 meters per minute to negative 100 meters per minute. At some time between 5 and 8, the velocity will be negative 100 meters per minute, not even graph. I would probably give you credit for that, but next time make sure you put somewhere in there IVT. So what is IVT? That's exactly what it means. You put it in words, you just didn't quote it. It just says, it just says if you've got two values, that at some point between those two values, it has to take on every value in between, is what it says. So, the mean value theorem. So that's where at some point, if you find the average rate of change, at some point the instantaneous rate of change has to take on that value. So A-rock will equal I-rock at some point in that interval between your endpoints. All right, let me tell you about the points and then I'll listen to yours. If you showed somewhere that the acceleration at 8 and the acceleration of 5, that negative 100 was in between those two values, that was a point. If you did set a conclusion with IVT, that was a point. Okay, it says conclusion using IVT. I would say you used the definition of IVT, you just didn't say intermediate value theorem. All right, what you got, Dylan?
I said
Just a second. I would say you would get 1 point, but not the IVT point. I said by the intermediate value theorem, because that happens, there must exist a point in between where it hits 100. That was my explanation. As long as you included that explanation, I would say yes. What was your question, please? You have to compare it to both values to get a point. Yeah. What you got?
So I said yes, IVT space is a differential function just for one that function.
Say that one more time.
IVT space is a differential function somewhere on that function.
I would probably give you 1, but not 2, because you didn't state the specific values that they were addressing, but you did correctly state IVT. So I'd probably give you 1 out of 2 on that. You can just say IVT. That's like in their glad they just said IVT. Yeah. All right, part C. Part C said at time t equals 2. This one was a bit confusing because they gave you a starting position. They said that your starting position was 300. This is train A. This was at t equals 2. East of the origin station, you like that, right? The origin station, you're on an origin, oh my gosh. And the train is moving to the east, okay? That's going to be important in the next part, or in the last part. Train's moving to the east. Write an expression involving an integral that gives the position of train A in meters from the origin station at time t equals 12. Then use a trapezoidal sum with 3 sub-intervals indicated by the table. Okay, so... All right, well, the first part just simply asked you to write the integral, right? So the integral here, now remember they gave you the position at 2. So I'm going to go from 2 to, what did I say? 12. From 2 to 12. So you need to make sure that you have correctly set up this, that's right, VA of t dt plus the 300. So there is your position expression, and that is 1 point. Okay.
What if I went from 0 to 12? Okay, because I'm technically the same thing.
Say that one more time.
If I went from 0 to 12,
no, because you have to take into account, because it said at t equals 2, it's 300 meters east. So they only wanted you to go from 2 to 12 on that.
I mean, yeah, but it's still the same amount of time. You know, like, it's still the same amount.
Well, so you...
I thought it was giving us at the number at 2, so it was getting number 12. Like,
I initially thought that too, and then as I started working it out, I figured out what it was. Because if we had been given an equation for velocity, and then we had that c on the end, that's where we would plug in and find that. You're exactly right. But here we have a table of values, and that's why it's a little different. All right, so just to go through quickly, let's see. All right, so there's my position. This is the position at 12. All right, trapezoidal rule. No, I don't think so. Okay, so then it wants the trap rule, right? So I've got, let me put this, actually, remember I'm starting at 2, 5, 8, 12, 140, negative 120. Area of a trapezoid 1/2, base 1 plus base 2 times height. Okay, these are going to be my heights. My difference is here. So my height would be 3. 1/2 height is 1 plus 2. My height here is 3. My height here is 4. If there's a formula they think you need, it will be embedded in the FRQ itself. That would suck. Yeah. Do not forget how to find the area of a trapezoid. Ingrain that on your brain. Okay, so base, right? So this makes up the first trapezoid. So, because remember, it gave me the position at 2. So from 0 to 2, I have that already. All right, so right now what I'm doing is I'm evaluating this with the trapezoid rule. So 1/2 height times base 1 plus base 2, 100 plus 40. My second trapezoid, 1/2 height is 3, 40 plus negative 20. I thought this was a bit extensive to not have a calculator. And then the last one, 1/2, 4, negative 120 plus negative 1. So you could, but the problem is I think you need it for part D. Maybe not. Okay, and then remember you've got that plus 300, which is that from 0 to 2. Just for the sake of time, if you do all this, you end up getting negative 150. This is just meters. Because it's position. Okay. Part D. This is the part where I'm hesitant to even show you this. Okay. Well, yeah, that's right. Okay, so for part D. Train B travels north. Which direction was train A traveling? Okay. If A is traveling east and B is traveling north, and you want to know the distance in which they are, it's a right triangle. I would have never put that together. And why, I don't know, but I just would not have. And I didn't. I could not. I was like, what the heck are they wanting me to do? So here's what they wanted you to do. Now watch this. They want to know the rate at which this is changing. So I'm going to call this C. They want the rate that it's changing. Okay? And they tell you at time t equals, what was it, 2? This is, I called this side A, I called this side, nope, yeah, side B, because that's the distance traveled there. At t equals 2, I know dA dt, I know I can find dB dt, because that's velocity, right? At time 2, what is A? How far at time 2? That's the velocity. At time, no, it gave it to us. It gave it to us. In part C, at time t equals 2, train's A position is 300 meters. It's not, but I do know the velocity at 2 because my table gives me the velocity. What's the velocity at 2? 300 is, I'm fixing to show you, because I got to relate these some way. Here's my related rates, right? No, it's equals 100, yeah. Right? I'm going to do a little implicit differentiation here. Well, before I do that, do I know B's distance at 2? It says at time 2, the train is 400 meters north of the station. Into the velocity, that's right. So VB of 2, 3 points. This was a third of the problem. This took me the longest of anything I did on this FRQ. The velocity at 2 of equation B, so I have to go to the second equation they gave me, right? That negative 5t squared plus 60t. You plug in the 2 and you get what? Oh, 125. Yeah. So this is 125. All right, so watch what happens. Can I figure out C from here? If this is 300, this is 400, that's an easy one. So 3, 4, 5 triangle. Now, explicit differentiation with respect to time. 2a dt. Remember, the variable I'm taking it with respect to is not in there. Okay, when we take the derivative with respect to a variable that's not there, I do the rule, but then remember whenever, usually we have y's in there, okay? So if I had the y, I would say dy dx, right? Same thing here, I'm taking it with respect to t. I'm taking the derivative of this equation, okay? Plus 2b to c dt. Now you can go in and plug in all of your known things. Solve for dc dt, and you will find, and I'm not going to go through all this because we're running out of time, and I want to make sure I get through the other stuff too, that dc dt comes out to be 160 meters per minute. That's okay. Look, I have A, right? A is 300. dA dt is 100. B is 400. dB dt is 125. C is 500. And dC dt is what I'm trying to find. Yeah. Okay, this one, scoring guide. 2 points for implicit differentiation of distance relationship. So if you set up the a squared plus b squared equals c squared and you implicitly differentiated, you got 2 points from that without doing any other type of calculation. And the answer was only 1 point. 2 points, 1 point. Every question is always 9. Okay, let's move on to the next one. I felt like A and B. Why did I start A and B? Okay, so part A, find the x-coordinate of each relative minimum. Y'all know me, and you know what I did, I'm sure. If it asks for a relative minimum, I did a sign chart, and then I explained my sign chart in words. It helps me understand. I know on the bottom goes the derivative, on the top goes the function. I know that I'm looking, because whenever I looked at this, this intimidated me. And I went, oh my gosh. You didn't have to do a sign chart. Okay, part 1, the x-coordinate of each relative minimum. So you had to say, let me read you theirs instead of reading you mine, because x equals 1 is the only critical point at which the derivative changes sign from negative to positive. Therefore, f has a relative minimum at x equals 1. 1 point. You need to say that the derivative changes signs from negative to positive. You got your point. Okay? All right. That's just 1 point. For that part A, yep. And then I said, you have to say, for some reason, they quit counting. Like, they don't even count sign charts anymore. You have to say it in words. The derivative, f prime changes from negative to positive at x equals 1. Therefore, and yes. However you want to say, there's the minimum. The one prior to this? Part C? 1. All right, part B, explain why there must be a value for C between negative 1 and 1 such that the second derivative is 0.
Yeah, how I just said the derivative from the so I said from negative 1 to 1, f times x. That's what I said. From negative 1 to 1, f times x will equal 0. So anywhere from negative 1 to 1, f times x is 0.
Okay, here's what they wanted you to do. Here's what they want you to do. A rock from -1 to 1.
Do we have to say that?
Okay, no, but you had to show a rock from -1 to 1, right? Because, why? Because it gives you 0. And if the average rate of change, is 0, then somewhere on that interval, the instantaneous rate of change is 0 by the mean value theorem. Well, you found it. It said between -1 and 1. So what you did was you found f prime of -1, f prime of 1. You found a rock between -1 and 1.
So was my answer okay or no?
0 and 0. So here's what they wanted to see. 1.4. You got 1 point for showing f prime of 1 minus f prime of -1 equals 0. That's 1 point. The other point comes from using your explanation of the mean value theorem. So those two theorems are, y'all need to really, really, really understand how those theorems work going back. You have to say mean value theorem because that is your justification. Mean value theorem in layman's terms, the average rate of change between two values. The instantaneous rate of change will take on that value sometime in that interval. So if you had the average rate of change was 5, you could say, then I know at some point the instantaneous rate of change is going to be 5, somewhere between those values by the mean value theorem. It has to take on that value. All right, C and D, I thought were gimmies on here. All right, part C. The function h is defined by the natural log of f of x. Find h prime of 3. Well, the first thing I did was find the derivative of h, right? So h prime of x, 1 over the log of f of x, and then chain rule says, oh, yep, sorry, get ahead of myself. Yeah, all right. And then it says find h prime of 3. So then once you plug in, this is literally, look at the chart. 1 over, what's f of 3? F of 3 is 7. What's the derivative at 3? 1/2. So it's 1 over 14. That was actually 3 points. Yes. You got 2 points for finding h prime of x. So this was 2, and this was 1. I thought that was a, yeah. D is -6. Did you get it? So D is the fundamental theorem of calculus. You don't have to. -2 to 3. All you had to do was recognize the chain rule in this. I just recognize. I remember whenever we said find the derivative of this, and we said the derivative of that is f prime of g of x times g. Well, that is the antiderivative of that. So all I have to do is this from -2 to 3. Okay, the antiderivative of this is this. Do you agree? Yes. So I do the antiderivative from -2 to 3.
I did f of g of x times g of x. Because you didn't need the g prime of x of chain rule.
Okay, so you do f of g of 3 minus f of g of -2. G of 3, again, these are straight from the table. G of 3 is 1. G of -2 is -1. Again, straight from the table, you get 2 minus 8, which is -6. This is another 3-pointer. All right, if you showed this, you got 2 points.
So what? F of g of x.
Yes, evaluated from -2 to 3. So in other words, you found the antiderivative and knew to evaluate on this. I would say yes because you still use fundamental theorem. Yes. Because you had to evaluate the integral. You can't evaluate the integral without the antiderivative.
Wait, so how
And then what? Okay, so 2 points for the integral for the antiderivative with the bounds. And then another point for the answer.
So, man, I did it right. I just thought I did it right, but I did it like the right way. I left the DFX there, not realizing that was because the chain rule was there in the first place.
Do y'all get more points on that one?
Okay, wait. How many was A and C?
I got yes.
A was 1, no, A was 1, B was 2, C was 3, and D was 3. That's awesome. All right, let's look at question 6 before we're out of time. I thought question 6 was the easiest. No. Part C was awful. All right, solution curve. You got 1 point for that. All of you figured out that little. Okay. All right. So you got a point for that. Part B asked you to write an equation for the line tangent to the solution curve in part A at the point 0, 1 using the equation to estimate f of 0.2. So I have dy. My dumb self didn't realize that they gave us the derivative equation in the beginning. I was trying to estimate the slope of that. And I went, surely they can't give us. And I went back and reread it and went, all right, so there's the derivative. So what I want to do is I want to find the derivative at, what was the point they said? 0, 1. So the derivative at 0, 1 would be 3 minus 1 cosine 0, which is 2 times 1, which is 2. And now I've got the point, so y minus 1 equals slope times x minus 0, of course. So my equation would be 2x plus 1.
I got it right.
Okay. 2 points for that one. 1 for the tangent line, and now I need to use that to approximate. So f of 0.2, which would give me, yes, when you plug it in 1.4. 2 points, 1 for each. 1 for the tangent line, 1 for the approximation. Part C was worth 6 points. I know, huh? 1. That's fine. The final equation was, they wrote it different than negative 2e to the negative sine x plus 3.
So I had y equals e sine x, e times e minus ln2 plus 3. Wait, I don't know.
Let's work through it, because you get points for a lot of different things here, okay? All right, so it asked me to find y equals f of x, the particular solution to the differential equation f of 0 equals 1. Okay, so I've got a differential equation, and I need to solve it, right? I have never seen an FRQ where you had a diffie-Q that you did not get points for separating the variables. In other words, put the dx with the x's, put the dy with the y's, and get them on different sides. That's a point all day long, every day. Okay? So, in other words, this dy equals, and this one goes over here, right? So I just wrote it like this. That is a point. Separation of variables. That is 1 point. You still get a point. Still get a point. Okay? That's still a point all day long. If you see a differential equation and they ask you to solve a differential equation, at least separate the variables, even if you don't know how to solve it, because you'll get a point. Watch. All right. Now I need to solve it. Now comes the hard part. So I integrate both sides, right? This is, well, because y equals f of x, you just find y. So they gave you the derivative, so you have to go backwards. That's all it's saying. All right. The key there, I didn't even look. I saw a solution to differential equation, and that's what I went on that one. All right. This is a natural log, but it's got a -1. If you think about the u substitution, right, I would have to do du would be -1 dy. So I need a -1, right? So this is going to be negative natural log 3 minus y. Yes, when you initially take it, make sure you put the absolute value. 2 points. All right, so this was 1 point. No, this was 1 point. This one is 2 points. The antiderivatives are 2 points. That's 2 points. Separation of variables, 1 point. Antiderivatives, 2 points. Okay. Say that again. Constant of integration, 1 point. Did you remember the plus c?
Oh, there's 1 point?
That's 1 point.
Like 1 extra point?
Yeah, that's not in the 2. That's another.
Oh.
So there's half the points right there. We haven't done any work, or not a lot of work. We separated the variables. We anti-derived. We remembered our constant of integration. We got 3 of the 6 points. We're 50% through that one. Okay? And we haven't done the hard part yet. Y'all with me? The initial condition was, what was it? 0, 1. Plug it in and find c. Okay? So, negative log 3 minus 1, the sine of 0, plus c. The sine of 0 is 0, so c is negative log 2. That's a point. Did you correctly find c? You use the initial condition to find c. Okay? Now there's only 1 point left, and that's for the answer. Did you solve it for y?
So even if you mess up the answer,
You messed up 1 point. Okay? So now I'm back to, where am I back to? All right, so I'm back to negative log 3 minus y equals sine x minus log 2. I'm going to divide both sides by -1. I can go ahead and get rid of these absolute values. I'm going to raise both sides to the e. Okay. Good thing this is the last part because this takes the longest and it's only a point. So if you're out of time or whatever. All right, if I raise both sides to e, I have 3 minus y equals e to the negative sine x. I'm going to change. Remember, if you're adding in the exponent, what I've really done, I can separate them, right? And I do that because I saw that natural log. So now I have 3 minus y equals, it does just equal to negative sine x times 2. So negative y equals, I'm going to put those together, 2e to the negative sine x, and I'm going to subtract that 3. And now you just need to negate everything, and that's your last point. And that's it. 45 minutes to take it, 45 minutes to explain them.